Have you ever looked up at the moon and wondered if it too could have a moon of its own? This thought might seem far-fetched, but let's journey together into the realm of celestial possibilities. Our quest begins with understanding what a moon's moon, or a submoon is, also known as moons, moonitos, or grand moons. These are hypothetical celestial bodies that orbit around a moon, just as a moon orbits around a planet. Imagine a tiny celestial object, dutifully trailing behind our moon in the vast expanse of space. It's a fascinating concept, isn't it? But for a moon to have its own moon, certain conditions must be met. The primary moon must be large enough and far enough from its parent planet to have a stable region in its orbit where a sub-moon could exist. This region is known as the Hill sphere. Within this sphere, the moon's gravitational pull is dominant, and it can keep hold of its own tiny moon. Now think about our moon. It's the fifth largest moon in our solar system, and it's quite a distance away from Earth. So on paper, it checks off the necessary conditions. But there's a twist. While the moon does have a Hill sphere where a submoon could potentially exist, that region isn't stable because of the gravitational influences of the Earth and the Sun. The Earth's gravity tugs at anything within the moon's Hill sphere, while the Sun's gravity adds another layer of complexity. These combined gravitational forces would likely cause any submoon to be pulled out of its orbit around the moon, sending it on a wild ride through space. So in theory, our moon could have its own moon. But does it? And if not, why? To unravel this lunar mystery, we need to delve deeper into the cosmic dance of celestial bodies and the invisible strings of gravity that bind them. So buckle up as we set out on this stellar adventure. Now that we know a moon can have a moon, let's dive into the implications. A submoon, or a moon's moon, could indeed have a profound impact on the celestial dynamics we're familiar with. For starters, its presence would likely influence the moon's orbit. Depending on its mass and distance from the moon, a submoon could create a gravitational pull, subtly shifting the moon's trajectory around Earth. This, in turn, might affect Earth's tides, as our tides are largely governed by the moon's gravitational pull. Imagine the high tide being a few feet higher, or the low tide being a few feet lower. This could dramatically change the landscape of our coastal regions and have significant implications for marine life. But it's not all about Earth. A submoon could also expand our understanding of the universe. It could provide us with new perspectives on planetary formation and celestial mechanics. If we could study such a phenomenon up close, we may uncover new insights into the workings of the universe. And let's not forget the tantalizing possibility of life. If our moon could support a submoon, and that submoon had the right conditions, it could potentially host life. That's a big if, but it's a possibility that could redefine our search for life beyond Earth. A moon's moon could change our understanding of the universe and even our place in it. We've explored the concept of a moon having its own moon and its implications, but what does all this mean? Let's take a moment to break it down. In our journey through this lunar mystery, we've discovered that it's theoretically possible for moons to have their own moons, affectionately known as submoons. A cosmic ballet of celestial bodies, each revolving around the other in a delicate dance of gravity and motion. We delved into the potential implications of such a scenario, and how it could dramatically alter our understanding of planetary systems. From the gravitational interplay between the planets, moons and submoons, to the potential for new, unexplored environments that could harbor life, the existence of submoons could open up a whole new world of possibilities. However, as we turned our attention to our own moon, we found that while it's theoretically possible, it doesn't have a submoon. The reasons for this are complex and multifaceted, involving factors such as the moon's gravitational field, its distance from Earth, and the chaotic nature of the solar system. So, while our moon may not have its own moon, the universe is full of endless possibilities and mysteries yet to be unraveled. Next time you gaze at the night sky, remember, there's always more than meets the eye. Before we close, let's take a moment to look ahead. What does the future hold for lunar exploration? With the concept of submoons now part of our scientific discourse, it opens up new avenues of exploration and study. The same principles that allow for the existence of submoons could also apply to other celestial bodies. This means that future space missions might not just be about visiting distant planets, but also their moons and potential submoons. It's an exciting prospect that could redefine our understanding of the universe. Recent advancements in technology have made space exploration more accessible than ever. Private companies are joining governmental entities in the race to explore the cosmos, pushing the boundaries of what's possible. So, who knows? it might not be long before we find the first evidence of a submoon. As we continue to explore the vastness of space, we are constantly reminded of how much we still have to learn. The universe is a vast, complex tapestry of mysteries waiting to be unraveled, and each discovery, each new understanding brings us one step closer to answering the ultimate question: are we alone in the universe? The search for submoons is just another chapter in this ongoing journey, so stay curious, keep exploring, and let's unravel the mysteries of the universe together.